So integration by substitution, the key is we need to find an inside function or embedded function. So we're looking for embedded functions where the embedded function's derivative will account for the outside part that's left over. Okay, so that's what we're looking for when we're looking for using this substitution. So where we often look is we look inside first. So in this example, we have x cos x squared plus 3. So we're going to look inside and try letting the u function be that inside function. So we're going to let the u function in this case be x squared plus 3. And what we then do is we generate a du by differentiating. So we differentiate this expression into 2x, and then we move the dx to the other part. And what we've then done is the derivative accounts for the leftover x dx. Now that 2 here, we can actually move it to the other side. So there's a few ways to deal with this. I'm going to deal with it like this. I'm going to just move it to the other side, and I'm just going to isolate the x dx, and I'm going to replace in my new expression. So then I can do a substitution here. I end up with cosine of the inside function. I'm going to replace it with u. And the x dx, I'm going to replace with a du divided by 2. And I'm going to put that divided by 2 on the outside because it's much easier to deal with on the outside. And what I've ended up doing is I've accounted for all the x terms. I've replaced the dx with the du and all the x's with u's, which means then I can just integrate this as a u function. So anti-differentiating this, well, the antiderivative of cos is going to be sine. And I did this in terms of u. Now again, I don't really want u in my answer. I'm going to replace then the u with my x squared plus 3. Okay, so there it is. There's my antiderivative of that original expression. So we don't have to check all of them, but right now we're just kind of learning this. So it's good to see how the chain rule can then justify what we just did. So I'm going to check this by differentiating. So I'm going to differentiate 1/2 sine of x squared plus 3 plus c. This is going to give me 1/2 cosine, and that embedded function I'm just going to leave. And then I'm going to apply the chain rule and differentiate that inside function times 2x, and I generated my original expression. Okay, so there it is. There's what I started with. So this must be the correct integral because differentiated is going to give me the expression on the inside of that integral.